Okay, real quick, let's go over these rotating biological contactor questions. These should hopefully be pretty easy for you. As you take a look at them, realize that unlike the primary clarifier and trickling filter problems, you don't have to calculate surface area in this case. It's going to be given to you in a problem about an RBC. So hydraulic loading rate is going to be in gallons per day per square foot, and organic loading rate, pounds per day per 1,000 square feet. So just like with the trickling filter problems, you have to take the surface area in square feet and divide it by 1,000 to get a number in 1,000 square feet. And I kind of mentioned this in class, but I think the reason they do that is so that when you do your final division problem, you get a whole number. Because a lot of these calculations we're doing just to compare loading rates to a standard loading rate. And when you're comparing numbers, it's just easier to compare a number like 26.15 to 24.33 instead of 0.26 to 0.24. It's just a little bit easier comparison. So I think that's the genesis of the 1,000 square feet and 1,000 cubic feet kind of unique units of measure. So these problems should be pretty easy. You've done quite a few of them by now. Again, just pay very close attention when you read the problem. So the next type of problem is this thing called K-value. And what we're doing with K-value is we're trying to estimate how much of the total BOD, or total biochemical oxygen demand, how much of that concentration is soluble and how much is particulate. And of course, soluble basically means that it's dissolved in the water, and then particulate means that it's that BOD is present in suspended solids. So this K value helps us convert the suspended solids concentration to an estimated concentration of particulate BOD. So it's almost like a conversion factor. And when I was writing up my made-up question, I didn't do the math before I typed it up. So I'm going to change this number to 190, and you'll see why when I finish the problem. So if the K value is 0.6 and the suspended solids is 240 milligrams per liter, we are going to use that to calculate an estimated particulate biochemical oxygen demand, and we do that through simple multiplication. So let's go ahead and multiply that out. .6 times 240 comes out to 144 milligrams per liter of estimated particulate BOD. And then since our total BOD concentration is 190 milligrams per liter, if we subtract the particulate, or our estimated particulate portion of that, from the total BOD, so this would be total less particulate. If we subtract our estimated particulate from the total, then what's left over is going to be our estimated soluble BOD, which in this case would be 46. So 46 milligrams per liter of estimated soluble BOD. So that's what K-factor is. It's just a way to take a known amount of total suspended solids and then try to estimate what part of the total BOD is particulate and what part is soluble. And these are just estimates. There would really be no way to determine that. So that's it. That should cover the math for this week. Again, not too many questions. And hopefully, as I said, they should be pretty easy because you've done a lot of this kind of stuff already. So good luck and get to work, and I will see you next Wednesday.